A little bit of both.
Alright, per request, you guys asked for one that was a little bit harder. At this stage, we actually have a choice.
Choice?
Yeah. You like choices, don't you?
I guess.
No.
Oh.
You don't like the buffet style eating, huh?
Not
No, not really. Too many choices.
Not buffet style, Matt.
Alright, the question was, let's get something a little bit harder. And somebody was asking me, well, can we put together product and quotient rules and do them at the same time? The answer is yes, we can. But when I say there's a choice, you do have the choice at this stage to go ahead and multiply those completely out. And so you get the trinomial over the binomial, and then you use just the quotient rule. You can choose to do that. And there's nothing wrong with choosing to do that.
Right.
But to help you see how the different rules fit together, I am going to go ahead and leave it alone like this and show you what happens from a quotient rule prospect. Okay? So just kind of bear with it a little bit. When we look at the rules, the one that really is going to apply to everything is the quotient rule, because I have the fraction. And if we recall, the fraction bar happens to be a grouping symbol. How many of you remember that? Not very many of you. The fraction bar is a grouping symbol just like parentheses are. So that means I have a separate numerator from a denominator. And what that really tells me then is if I collect all of this numerator together, that is actually my u. And then again, down here in the denominator, the 5x plus 7, that is my v. So as a first step, we have to identify the u and the v. And then we want to go ahead and take what is the u prime, what is the v prime, so we can look at it and isolate it and that kind of stuff. Now when it comes to taking the u prime,
Is it 12?
It's 12x.
well, isn't it a quotient? Or isn't it a product?
So we're using the product rule.
So we use the product rule to actually find the u prime. That's where we put the two pieces together.
Okay.
So then,
12x minus 18.
if we apply the product rule correctly, what's the derivative of this part?
6.
Times the 2x minus 4 plus, what's the derivative of this part?
2.
Times 6x plus 3. And again, over here it's alright to go ahead and do some of the algebra. 6 times 2x is 12x minus 24 plus 12x plus 6. And so we see that u prime is
24x minus 18.
I do it the other way.
So you multiplied it out, and then yeah, we'll get the same result. Good. So we have written a u prime now. What else do we need to write?
V prime.
Boy, wasn't that nice. Okay, everybody clear on that? All right, so now let's go ahead and write out the derivative. I need to move that for a minute. So what do I write here first?
24x minus 18.
Because that is? So we had, remember, u prime times, which is?
5x plus 7.
Oop, I'm going to grab too much. Get back up there. Okay, is everybody clear on that? I have minus. What comes next?
5.
Because it is. And then what do I multiply it by?
6x plus 3 times 3, or 2x minus 4.
So you're picking out this thing right here, right? 6x plus 3 times 2x minus 4.
And if you had counted it out before to the trinomial, could you just put the trinomial?
You mean if I multiplied it out before? Yes, I would just put the trinomial. Exactly.
I feel like that's easier.
Over 5x plus 7.
Okay. Do you have any questions about that? Guess what we get to do now? You won't nothing. Actually, we get to do a lot of fun stuff.
Yeah.
Now we get to do the algebra part of it. There's going to be a saying that we have in here. Calculus is over, now let's do the algebra. And you're going to discover that calculus is typically about one line, algebra is about 6 or 7 lines.
Alright.
So that's going to be consistent in here. It's not going to be unusual for us to have a small bit of calculus and a whole bunch of algebra. So we need to be careful with our algebra skills. If you are a solid algebra student, calculus is not too bad. If you are a struggling algebra student, calculus gets really hard. So that gives you a sense of where we're going with this thing, but you need to understand your algebra. So that's what's next. We ready?
Yeah.
120x squared.
So 120x squared, let's get the 120 on there.
It's 168x.
Plus or minus?
Plus.
Plus 168x
Minus 90x.
minus 90x.
18 times 7. 56, 7, 120.
Thank you. Good job. Now we might,
60x squared.
yeah, we might need to take 5 times. We'll do that in a second. And then we'll go ahead and multiply this out. Say 12x squared minus 24 plus 6, so minus 18x minus 12, and then we'll distribute the 5. And by multiplying out the denominator.
Well, you're going to get a trinomial over a trinomial, so could you?
And you could, but the answer is no. We want to leave it like that in case what's produced up here has a factor that turns out to be 5x plus 7. I need to know that. So we know with f prime of x is 120x squared plus 100, no, let's put those two terms together.
78.
Thank you. Minus 126 minus 60x squared,
Minus 90x.
no, plus,
Oh, yeah. Plus 60.
thank you, over 5x plus 7, the quantity squared. So what's f prime of x?
Is it plus 7 or minus 7? I don't know.
I
I
think
had
it's
minus
plus
7.
7.
and-
Well, let's check it out. It's plus 7.
Oh, okay.
Good question.
So 60x squared plus 168x minus 66.
Wait, I thought 78.
I combined the 168 and the minus 90 here.
So how many 168 doesn't matter.
Oops. All right. Now, the question we really need to ask ourselves is, does 5x plus 7 evenly divide 60x squared plus 168x minus 66?
No.
How do you know that fast? Because I don't want to. Because you don't want to. Okay, that's not a good excuse.
Because 7 doesn't multiply into 66.
That's the real question. Remember, if it's a factor, as we set up our factoring, the 5x is multiplied to something to get 60x squared. Well, that's 12x. It could happen. But the 7 has to be multiplied to some other integer to make 66. And there is no integer times 7 that makes 66. So we can then conclude that no, there's not a common factor. This is it. We're done with it. Does that make sense?